Lesson 2, we're going to be taking what we learned about linear equations and solving linear equations to being able to solve some real-life application situations. Um, so, before we get started, there was a real famous mathematician guy. His name was Polya, and he wrote a fairly famous book, How to Solve It. And he came up with 5 steps to solving problems. Now, this isn't necessarily going to be like practical for every problem that you have to solve, but it is fairly practical for algebra-related problems that you have to solve. So, his first step was simply to read, but more importantly, to understand the problem that you're faced with. Until you understand what is the question, what bottom line are they asking you to do, you really don't have anywhere to start. Step number 2 is to be able to identify some sort of variable. Once you have figured out what problem you're trying to solve, well then, take what you're trying to solve for and make that some sort of variable. Step number 3 was to write an equation. So using that variable, put together an equation. I'd say that this step right here is generally the toughest thing to do. And so a lot of times it's good to know some just common formulas for real life situations, and that's a great place to start. Number 4, once you've got an equation written, solve that equation. Usually at this point, especially with linear equations, solving it is not the difficult part anymore. But then finally, the last step is to check your solution. Anytime we have a solution to an equation, that solution is what value makes that equation true. So you can always plug that back into the equation that you wrote, and everything should make sense. All right, so let's take a look at some of these problems that we've got. First one. Again, before I even read most of this stuff, I'm just looking to see if I can find what is the question. Then I'll go back and read it, kind of knowing what I need to find. So here, usually at the very bottom, says find the dimensions of the original square. Okay, so I know that I'm looking for dimensions. So it says if the length of each side of a square is increased by 3 centimeters. Well, that means if I've got some sort of square, and again, what I'm trying to find is the dimensions of this square, that's probably going to be my variable. We'll make it x. And then the dimensions of my new square are going to have, well, dimensions that are increased by 3 centimeters. So it's the original stuff plus 3. So x plus 3 and x plus 3. Well, we do know that the perimeter of the new square, so remember, what is perimeter? Well, for a square, it's 4 times the length, since all the lengths are the same. So the perimeter of this square is going to be 4 times x plus 3, which would in turn give us 4x plus 12. The perimeter of our new square is, keyword here is, if algebra were like a foreign language, is means equals, is 40 more than twice the length of the original square. So I can use this kind of to make an equation. The perimeter of my new square, well, here's the perimeter of my new square, I've got that. 4x plus 12 is means equals. 40 more than, well, that means 40 plus. Sometimes students get more than confused with the inequality, like is more than. But remember, is more than is greater than. More than just means plus. Twice the length of the original square. Now, reading this upon first glance, you might think, oh, is it talking about the perimeter or just the length? Well, I think the way that this reads, it is much more just the length of one of the squares. So just twice x. All right, well, I would say that that's the toughest part, is writing the equation. Solving is not going to be that difficult at all. We subtract 2x from both sides, and we wind up with 2x equals, well, 40 minus 12 is going to be 28. And then divide both sides by 2, and we get x equals 14. Okay, and so if we need to, we could write a therefore statement. We could say, therefore, the length of the dimensions of the original square is 14 centimeters. All right, that's it for number 1. Number 2, we've got 2 people, Maria and Eduardo. We'll just call them M and E for short. So we've got Maria, we've got Eduardo, and they're both traveling to the same business conference, a certain number of miles away. All right, well, the trip takes 2 hours for Maria, again, and 2.5 hours for Eduardo. All of this stuff here is just kind of not making a whole lot of sense to me until I find out what we need to solve. And right here at the very end it says find their average rates. So how fast is Maria going? How fast is Eduardo going? Well, I look at this and I think to myself, all right, do I have any real formulas for something like this? And I do, actually. I know that distance is equal to rate times time. And so for me, rate, this is what I want to find for each one of them. So R is going to be my rate. This is what I want to find. That's my variable. Now comes the tough part of writing the equation. Well, in the last example, it was kind of drawing a picture. That helped me see how my equation came together. I think this time a table might be real nice. And so I'm going to do distance and then time and then rate. Okay, and I've got this for Maria and I've got it for Eduardo. Okay, and this is going to kind of help me piece these things together. Because what do I know? As I go through here, what do I have? I know that the trip takes 2 hours for Maria, and it takes 2.5 hours for Eduardo. So for time, I can put that here. 2 hours for Maria and 2.5 hours for Eduardo. Right? The rate, well, the rate is my x, okay? That's what I want here. That's what I want to find. And so, well, the rate, well, I don't have any idea how fast Maria goes, but I do know that Eduardo travels 5 miles an hour faster than Maria. So I'm going to say the rate is x for Maria, and I'm going to say it's x plus 5 for Eduardo, since Eduardo goes 5 miles an hour faster than Maria. And now distance, well, I know that distance is rate times time. So Maria's distance is going to be 2 times x. And, well, since they're going to the same place, I know that Eduardo's distance is going to be the same as Maria's, 2x. But it does say that Eduardo lives 40 miles an hour farther away. So he's going to travel another 40 miles. Okay, so because these things have to be the same, or in other words, the distance that Eduardo travels, so the distance that Eduardo travels is going to be, well, 2.5, or I guess, yeah, it's the distance equals rate times time. So, sorry, the distance here that Eduardo travels is not 2x plus 40, it's 2.5 distance times, distance equals rate times time. So 2.5 times x plus 5. Okay. So the distance that Eduardo travels is going to be 2.5 times x plus 5. Okay. And this is going to be equal to the distance that Maria drives, 2x plus 40. Okay? So Eduardo's distance traveled, so this is Eduardo's distance traveled, is Maria's plus the 40. And that's why we add it to kind of Maria's instead of adding it to Eduardo's. Because we already know Eduardo's distance is this. All right, so again, now that I've got the equation set up, the rest is kind of a piece of cake. I'm going to wind up with 2.5x plus 5 times 2.5 would be 12.5 equals 2x plus 40. I go ahead and start solving for x. I subtract 2x from both sides. I'm going to get 0.5x equals 27.5. And then I divide both sides by 0.5, and I get a nice even 55. Now, what does this 55 mean? Again, kind of Polia's thing, going back, checking it, at least thinking, is this a reasonable speed for someone to travel? Yeah, 55 miles an hour is no problem. So this is Maria's speed, okay, because remember what did x stand for? X stood for the speed or the rate that Maria was traveling. Okay, so this is Maria. And Eduardo, well, we know that his is 5 miles an hour faster. So he would be traveling at 60 miles an hour. Okay, so again, we'd probably have a therefore statement. It would say something like, therefore Maria is traveling 55 miles an hour, Eduardo is traveling 60 miles an hour. All right, third one, these percent problems. The thing that's going to help you the most here, just like before, we had kind of a formula for distance equaling rate times time. Here, the percent concentration times the quantity, or the amount of the solution that we have, is going to be equal to the purity of our solution, okay? And so, as we look here, I'm looking for, what am I trying to find? I see the question, how many liters of the 15% solution? Okay, so again, I think this would be a good table one. I would set this up. The liters of 15% solution is what my variable is going to be. And then should she add to 3 liters of 30% solution to get her 20% solution? So now that I've got this, I'm going to kind of take what I know about the purity of a concentration, and I'm going to go back and read through the problem to figure it out. So it says she needs a 20% solution of alcohol. So whatever it is, the purity has got to be 20%. She has a 15% solution on hand and a 30% solution. So she needs it to be somewhere in between, 20%. All right, and she's going to mix them together to get her 20% solution. So here's what I've got. I know that I have some 15% solution. And what I need to know is how many liters of that. I'm going to call that X. So here is my percent concentration. Here is my quantity. And so my purity is going to be over here. And so if my purity is these two things multiplied together, I'll say, all right, 0.15x. All right, I also have some 30% solution, and I actually know how much I have of that. I have 3 liters of it. So my 30% concentration, I have 3 liters of that, so my purity is going to be 0.3 times 3. All right, and then finally, what I want is I want a 20% solution. And, well, again, what I'm going to be doing is I'm going to be mixing them together. I'm going to be adding the 15%, which I don't know how much I have of that, plus my 3 liters. So the total quantity is going to be X plus 3. And then, of course, down here, I'm going to have, I want it to be 20%. So, I'm still just doing this times this to get my total purity. So 0.2 times x plus 3. All right, so again, now the tough part is kind of just putting it together to make an equation. I'm going to take my 15% stuff, which gives me 0.15, so 0.15x, plus my 0.3 times 3. So here I'm mixing my 15% stuff with my 30% stuff, and I want this to equal 20% purity of the whole thing. So 20% times x plus 3. All right, now that that's all set up, I'm just going to go ahead and solve for x. And again, this is not really the tough part anymore for us. We'll just say 0.15x plus 0.9 is equal to 0.2x plus 0.6. We'll start combining like terms. We're going to wind up with 0.3 equals 0.05x, and divide both sides by 0.05, and we get 6. So again, what did x stand for? Well, x stood for the number of liters of 15% solution that'll give me this. So again, I'd put a therefore statement. I'd probably say something like, therefore, I should mix 6 liters of 15% solution to get my 30% solution. All right, last one here. We've got an artist, and an artist is selling a painting, or sold a painting, for $410,000. Must be a really fancy painting. He's going to need some of the money in 6 months and the rest in a year. Again, I'm probably just going to stop right here, and I'm going to go and see if I can figure out what is it asking me to do. How much money should be invested at each rate? So I'm going to kind of have to find two things, kind of like that second problem, to obtain the amount of interest. Well, how much interest? His broker tells him the two investments will earn a total of $8,000. Okay, so here's what I've got going on. I got two things. I got the bond for 6 months at this rate, and I've got the one for 1 year at this rate. And so I'm trying to think, what kind of formulas do I already know that relate to interest? Well, one of the simple things is the simple interest formula. The amount of interest equals the principal times the rate times the time. Okay, and so again, I can kind of set up a little table here. I'm going to say, all right, I've got the two things. I've got the thing for 6 months or half year, and I got the thing for 1 year. Okay, this would be the time. And then I've got the principal. Now, for the half year thing, well, I don't know how much that is. I'm just going to say that's X. But the other thing, however much I invest in the second one for a year, I'm going to just say that that's the original, however much I started with, 410,000, minus whatever I invested in the first one. Okay, so if I invested $1 in the half-year thing, well, then I would have 410,000 minus $1 that I invested in the 1 year thing. All right, and then of course the rate is going to be the other thing, and well, the 6 month rate is going to be as a decimal 0.0265. And then the rate for the 1 year thing, that was up here, that's going to be 0.0291. All right, and so the interest of the first, so interest of the 1 year, so 12 months, plus the interest of the thing that I had for 6 months, has got to be equal to the total interest that I earned, which is going to be 8,761. Okay, so that's kind of how I'm going to put these equations, or this equation together. The interest for the 6 month thing, well, would be the principal times the rate times the time. So principal X times the rate 0.0265 times the time, 0.5. Okay, so I've got that. And then plus the interest for the 1 year thing. Well, again, that's the principal. So 410,000 minus the x principal times the rate, 0.0291, times the time, which would just be 1. This needs to equal the total, 8,761. All right, well, again, at this point, solving the equation isn't going to be the tough part, but I'll start kind of combining everything here, and I'm going to wind up with 0.01325x plus 11,931 minus 0.0291x equals 8761. Okay, so just using the distributive property here and just multiplying those two things there. Now kind of putting everything together, combining like terms, I'm going to have negative 0.01585x equals negative 3170. So subtracting 11,000 from both sides, combining these two like terms, and then dividing both sides by my decimal. I'm going to wind up solving for x, which is, interestingly enough, a nice, cool, clean 200,000. So this, remember, the x stood for the amount that I invest in my 6-month thing. And so this is what I'm going to put in the 6-month bond. And so I'm going to subtract that from 410,000. That would give me 210,000 in my 1-year bond. All right, well, that's a little bit on problem solving with linear functions. I would say kind of the things that you're going to want to have memorized are these simple formulas that really help us setting out up together. And then just the process. Put together a table. These tables are really helpful for doing the hardest part, which is putting together the equations. And then don't make sure that you don't make any careless errors solving it, because, well, that's the easiest part of the whole thing. So that's it.